Human intelligence relies on a complex overlap of mental abilities. We use reason to solve problems, pick up on subtle emotional cues from others, and constantly learn how to behave based on the context of our surroundings. These biological neural networks physically rewire themselves to find new solutions, like timed traffic lights or microwaves, perform their tasks automatically, which creates an illusion of cognitive ability. This vintage traffic control box relies on hardwired mechanical logic. It follows rigid pre-written instructions, unable to observe the road. It requires one specific input, a car horn. The output remains identical because the machine cannot rethink its programming. If the environment changes, for instance, if a driver's horn is broken, the automated system cannot adapt. It lacks the human capacity to assess a new situation and devise a backup plan. Executing a list of predetermined commands flawlessly qualifies as mechanical compliance rather than true intelligence. Developing actual artificial intelligence required a shift away from hard-coded rules. Researchers began feeding machines massive streams of raw data instead. This process is known as machine learning. By using algorithms to analyze data, a computer identifies recurring patterns and improves its performance over time, without a human programmer writing every step. Supervised learning is the most common starting point. This method trains a model using a dataset where the correct answers are already known and labeled by humans. Here, the system scans thousands of geometric shapes. Each shape has been assigned an explicit text tag by a person, allowing the machine to learn the relationship between the image and the label. The system uses those known examples to build predictive trend lines. This is the underlying technology used to recognize handwritten digits on bank checks or estimate the value of a house based on historical sales data in a specific neighborhood. While these systems can achieve high accuracy, their understanding remains tethered to the specific definitions and labels provided by their human trainers. Unsupervised learning takes a different approach. The machine receives a chaotic mixture of unlabeled data points. The algorithm explores independently, looking for hidden structures, which results in clustering, grouping similar data points together. Banks use this to find unusual transactions that indicate fraud, and social networks use it to find communities with shared interests. Finally, reinforcement learning focuses on trial and error. The AI, acting as an agent, interacts with an environment to see which actions lead to the best results. The system operates on a continuous feedback loop of rewards and penalties. Successful actions that lead toward a goal trigger a mathematical reward, which the system then tries to maximize through repeated attempts. This continuous optimization allows AI to master complex tasks where the rules are clear but the possibilities are vast, such as autonomous driving or playing strategic games like chess. These machines simulate the way biological creatures learn, but the system is solving for a mathematical score rather than experiencing genuine curiosity or purpose. Machine intelligence is highly efficient at processing enormous amounts of data. It executes specific, narrow tasks with speed and consistency that humans cannot match. Human intelligence remains unique in its capacity for original creativity and its ability to respond to emotions, qualities that emerge from biological evolution rather than programmed algorithms. We also possess a unique ability to navigate entirely novel situations, where historical data simply does not exist. No matter how complex its output appears, an AI's behavior remains fundamentally bound by the logic of its code and the specific information used to train it. AI functions as a data-driven toolset, serving as a distinct category of intelligence meant to support human decision-making in a complex world.